Now we are going to find the interval of x for which a given function is decreasing. Let's do a recap for the decreasing function. We said that this is how it looks like, and as calculations, f prime of x is less than 0 in the interval x between a and b, so the gradient is negative. Look at this example. Find the values of x for which the function f of x is x cubed plus 3x squared minus 9x is a decreasing function. Let's start. This is the function f of x. Since f of x is decreasing, thus f prime of x is less than 0. Let's do the differentiation. We will bring the exponent down, so 3, and we subtract the exponent by 1, so 3x squared plus 3, we bring down the exponent 2 and we minus 1, so 2x to the power 1 minus 9. The differentiation for x is 1. So f prime is 3x squared plus 6x minus 9. Since we have a decreasing function, we need to prove that f prime of x is less than 0. However, first we need to factorize. We take the 3 as a common number. Then we write x squared plus 2x minus 3. We are searching for factors, where if we multiply them, we will get minus 3, and if we add them, we will have plus 2. So, x plus 3 and x minus 1. We need to prove the following. 3x plus 3 into x minus 1 is less than 0. Okay, here we have two cases. Case 1, this is negative and this is positive. So, x plus 3 is less than 0 and x minus 1 is greater than 0. If we multiply them, we will get negative because the 3 has a positive sign, so it doesn't affect. Okay. Here, x is less than minus 3 and x is greater than plus 1. Let's represent them on the number line. Here we have 0 and we take the 2 points, minus 3 and plus 1. X is greater than 1, so it's going to be like this, and x is less than minus 3, so it's going to look like this. Do we have an intersection between these lines? No. That means this case is rejected, so case 1 will not be accepted and we will look into case 2. The solution is to switch the signs. This is positive and this is negative. Okay, now let's see case 2. X plus 3 is greater than 0 and x minus 1 is less than 0. So, x is greater than minus 3 and less than plus 1. Okay, now let's represent these points on the number line. This is our number line, and here we have the 0. Then we will plot the 2 points, minus 3 and plus 1. X greater than minus 3, so it's going to be like this, and x less than 1 is here. We have an intersection in the values here. This is our intersection. So x is between minus 3 and 1, without the equality because we want it exactly less than 0. So the interval for which this function is a decreasing function is between minus 3 and plus 1. Look at the discussion in the book. We took the function and the gradient. If f prime is negative, then it will have this form. Solve the inequality by factorization and by considering the three regions, x less than minus 3 and between minus 3 and 1 and greater than 1, looking for sign changes. And finally, we state the answer. Now you need to solve these exercises on your own. You need to find the values of x for which f of x is either increasing or decreasing. You simply do the differentiation, define the gradient if it is positive or negative, then you represent the values of x as an inequality on the number line, just like we solved this example.